Hey folks, I'm Vinay Gaba, and I'm very excited to be here and talk to you about a topic that a lot of people in the Android community are very excited about. And so, my topic for today is going to be Jetpack Compose, a declarative future for building Android apps. Before I get started, I want to quickly go over my background. And so, I've been a Google developer expert for Android since about a year now. I've been involved with the Android ecosystem since 2011. A fun fact about me is that every dollar I've made in my life, it can single-handedly be attributed to Android. And so you can imagine that I'm very passionate about this since I've been doing it for almost 12 years now. I'm the creator of a website called Jetpack Compose app, an open source library called Showcase, and another open source project called Learn Jetpack Compose by Example. I've put in a lot of effort in maintaining them, so would love if you all check it out when you get a chance. I was recently featured at Google I/O, and so if you want to dive deeper into the kind of stuff I've been doing professionally, that's a great place to take a look at. And I've helped build some of your favorite apps, or at least hopefully some of your favorite apps. I do want to add that I'm here in a personal capacity, and my views don't represent the views of my employer. And with that, let's get started. All right, so I know that this audience is a mix of all backgrounds, and obviously, we love to see a diverse audience. So let's dive into what exactly is Jetpack Compose. And so, by definition, Compose is a declarative and modern toolkit for building native Android UI. It simplifies and accelerates UI development on Android. Now, I'm confident that none of this made sense to a lot of y'all, and that's completely fine. By the end of it, hopefully, some of this starts making sense, and you will appreciate why I'm so excited about and then spend so much of my free time working on this. All right, so to get started, if you are familiar with React, what React did for web, Compose is trying to do exactly that for Android. And for people who are familiar with the web ecosystem, you know how important React is to that world and how almost every company is using it in some form or another. It's also helped inspire other frameworks, for example, like Flutter. And so the Compose is trying to do that for the Android ecosystem. It is a pretty dramatic shift. And I would say it's a paradigm shift to Android development as we know it. It is a complete rewrite from the ground up. And what I mean by that is that whatever you used in the old world to build your UI on Android, Google essentially decided to rewrite all of that. And so this decision is not taken lightly. Like it's a very massive investment. In fact, rewrites are always controversial decisions. And so you can imagine why this was needed. And we'll dive into the whys very soon. What we've also seen is that the community is embracing it with open arms. Everyone is super excited about it, and that's why, in fact, we are talking about it at this event. We also know that it's all probably here to stay, and all the early signs are pointing to that. And so, it would be wise for us to pay attention to it, especially because this is going to be an ongoing topic for the future years. All right, so let's talk about the why. Like, why was a complete rewrite even needed? And there were a few factors that led to this decision. And the first one was that the existing UI toolkit, which is the view system, was tied to the operating system itself. And what I mean by that is that you might have heard Android releases. So, for example, Android KitKat or Android Oreo. The existing view system that we were using as Android developers, it used to be embedded in the operating system. The problem with this, though, is that the release cycles are much slower. And so people have to wait for these releases to go out. In addition, whenever an OEM, and I don't want to take any names, but whenever an OEM decides to create their own version of the operating system, they have the power to actually override some of the view system stuff as well. And so, as Android developers, we would struggle with issues where we would see some devices showing a different behavior. And that's very painful to manage as an Android developer because there's so much fragmentation, and this wasn't ideal. So Google needed a solution to move the view system out of the operating system into its own library so that the release cycles are faster, you're getting more bug fixes easily, and there's some level of consistency across the different uh, models of devices that people are using. The second reason was that there's a lot of context switching that's happening. Like historically, we create our UI in XML files, and then we write our business logic in Kotlin files, and we move back and forth between these two systems. There was no real good reason to have this context switching, and ultimately, it requires cycles for us to think through these things. People also tend to love Kotlin more than XML, so why can't we actually create our UI in pure Kotlin programmatically? Like, there's no reason to not do it. Just that the way the existing system was constructed, it wasn't easy to do it. Obviously, without Compose, that is. Finally, I think simple things required a lot of code. And so, if you imagine the use case where you're trying to create a list of things, we use something that we call recycle view, which requires a lot of boilerplate for you to write. Now, if we think from a four principles point of view, a for loop is also a list. If a for loop is a list in the programming world, why do I need all this dance around trying to create a list? And these were things that were happening in the old view system, but someone needed to come in and think from a first principles point of view. And the last thing why this was needed was that state management is often very tricky in the old system. In fact, most of our bugs stem from the fact that we are doing state management in a way that involves multiple sources of truth. So, as an example, and again, if you're not familiar with these terms, it's fine. Uh, and maybe we can talk through some of these things. But imagine a use case where you're storing some state in the view model, then you go to the view and tell the view to do something. The view itself also had some internal state. And again, this isn't ideal. And we wanted to make sure that we had a single source of truth. All of these reasons were why Google ended up deciding that it made sense for them to potentially rewrite the view system from the ground up, because it's very difficult to make changes when you've added code for the last 12, 13 years, which was the state of the old view system. Decoupling from that and starting from the ground up allowed them to make decisions that would not tie them to the existing way things were implemented. All right. So anytime you're talking about a programming framework or any programming concept, uh, we obviously have to start with an Hello World example. So that's what we'll see. Uh, by the way, I'll be using Kotlin because Compose requires you to use Kotlin for its development. If you're not familiar with it, it's fine. Don't focus too much on the syntax. Think of it as reading English, and that's the goal. Like, I want this to be a conversation more than a presentation about code, because that's not the goal. All right, so there are a few things going on. Let's talk through what we see on the screen. So you see an annotation called add composable, and I've created a function. Fun is what we use in Kotlin to define a function. I'm calling it hello world, and internally, I'm calling another function. This is one of the defaults that Compose provides for rendering text on the screen. It's called text, and I simply pass a string to it called hello world. This is all that is needed to render something on the screen. Now, I don't expect this to blow your mind, obviously, because ultimately all we are doing is rendering some simple text on the screen. But there are a few unique things about this, and it depends on how you view it. So, for some people, this composable function uh, might be a function. Like, it's a function, that's what we see, and that's accurate. Some people might say that it's a view because I'm rendering something on the screen using this. This is also accurate. Some of you will say that it's probably a layout, right? Because it's defining how something should be rendered on that screen. Again, that is still true. You can also say that this is a custom view because now I've created my own view that's wrapping another view inside it. And again, this is also true. Funny enough, this also can be a screen. You can define the entire rendering logic of a screen in this single function. All right, so now that we've seen Hello World, why don't we jump into creating a more simple component that we are used to building in our day to day? And so all of us have seen components that look like this. Essentially, you have some sort of an image view on the left and a title and a subtitle in this card. And so what we're going to do is break down what we see visually. So what I'm seeing right now is a row. This row has two children. The first child is a simple image view of sorts. The second child of this row is essentially a column that has the title and the subtitle. And so I said a few things in English. Let's translate this to Compose code. And so I'll start off the same way that I previously started off. I've created a custom function annotated with at composable. And whatever I just said, I will spit that in code. So I am creating a row whose first child will be an image, and the second child is essentially a column. This is just the skeleton code that I'm adding. The funny part here is that Compose actually has composables with these exact names. So what you see on the screen is what I'm writing in code. And the way I described it was in English. And the way I've written this code is also technically English. Uh, and it feels like that too, which is, think, the more interesting part. And so I'm using my first child as some composable that I'm calling image. Doesn't matter what it's called, really. Because I just want you to follow along with the example of how I'm structuring the code. And inside the column, I'm calling the same composable that I used previously to render the hello world text. But instead, I'm passing different text to this composable. And this is it. You've just created a custom component that does what you want. Obviously, I've not added any styling information to keep this example very simple, but you can see how simple it is to use Compose and it feels like English. This is very important, and I keep reiterating this because it removes barriers to entry. When something is easy to understand, more groups of people can embrace programming, can become Android engineers. And I think it's a pretty big deal because Android, for example, changed my life completely. I would love for more people to be able to experience that. And I feel like Compose is a step in that direction, even though it's not spoken about enough. Or rather, this example of Compose is not spoken about enough. All right, so I think this is where hopefully I can blow your minds. So, what I'm going to do is display a list. And it's important to see where we started from. Essentially, this is the kind of screen I'm trying to create. I want to use the same component I created in the previous example, but render it multiple times on the screen. At this point, I want to see how we would do it in the old system or the classic Android view system. This is all the code that you would need to create a list in Android, and it does not even include the XML files, which we also need in order to render this. And so, as you can see, I probably need 50, 60, 70 lines of code to create this experience. Let's look at how we would do this in Compose. So again, the way we start is identical. We create a custom function annotated with the at composable, and I pass in the data that this function might need. In this case, I'm passing a superhero list to this composable function that I want to then use to render on the screen. And so I'm going to use the lazy column composable. I pass my data object to it. And inside, I essentially want to use a simple row component that we created in the previous screen. I added a few more parameters. Doesn't matter. It's essentially the same component. And after this, obviously, we need to do a lot more, right? Funny enough, we don't. This is all the code that's needed to render a list on the screen. When I look at this, I always wonder why isn't this how we started with? And I feel like we're 10 years too late, but better late than never. And I'm so glad that we are in a world where this actually feels like a for loop itself almost. And this is how it should be, right? Like if you think from a first principles point of view, this is what a list is. So why shouldn't we reflect that in the code be, right? Hopefully you can see the value, like how much more productive it makes you because you're not writing all that code. One more advantage of writing less code is that you're maintaining less code, and automatically the best way to avoid bugs is to not write the code itself, because humans will always make errors and always have bugs. Like that's just how things go. And so if we can avoid writing that code, there's nothing better than that. All right, so just to summarize what we've seen so far, about the benefits of Compose, essentially Compose is Kotlin first. You can define entire screens in pure Kotlin code, which is a developer favorite language. It requires less code, which also means that your build times are significantly better. This is one of the big pain points that developers face. We've seen that it can reduce development time by one, using less code, and two, you can see those live previews in Android Studio itself, so you don't require builds. Again, something that developers love to do. One thing I didn't point out with an example, but I want to call out now, is that it's completely interoperable with the existing way of building Android. So you don't have to rewrite your app. You can just create a composable component and use it in the existing screen, or vice versa, use something that you created in the view system, but use it in Compose. It brings declarative programming to Android, which is essentially what React is trying to do. That React is trying to do for web, and some of the APIs are super powerful and intuitive, and developers seem to love them. Finally, I have some takeaways for founders, which is if you are starting a greenfield Android app from scratch, I strongly encourage you to use only Compose for doing that. I think you will thank me 2 years down the line, and I feel very good about this after having almost spent 3 years working with Compose. I also think that Compose is going to be a recruiting advantage where developers tend to be picky and they want to work with tools that make their life easier. And also, they want to use tools where the industry is headed. Compose promises to certainly be that, and all the early signs are pointing to that. I also recognize that one of your biggest problems for any startup founder is hiring. And so, if you're looking for Android developers, I think I can help. It's primarily because I run a job board focused on Compose and Android. And so, I am around people that are looking for jobs. So, if I can help you that way, I'll be more than happy to. And with that, I want to thank you for listening to me ramble about something that I love. Um, Thank you so much for giving me those valuable minutes of your life. If you want to reach out or find me, you can find me on Twitter. My handle is Vinay Gaba, or you can email me, and it's identical. It's vinaygaba@gmail.com. So please feel free to reach out. And that's it. See y'all.